Good morning, everyone, and it's a real honor to be on this stage talking to you on generative AI. Uh, they asked me what is going to be your, the title of your talk. I said the title of this conference itself will be the title of my talk because this is exactly what we are trying to do. So I'm an orthopedic surgeon. So by training, I have nothing to do with AI or generative AI or anything. So after having worked in many hospitals, uh, I even worked for United Nations. That's when I came across the power of technology. And Mr. Sandeep is not there. Thanks to his company, it had a great role to play. I was in United Nations, and my mandate was to build a lot of trauma centers across many war zones in Africa. So like countries like Somalia, Mozambique, and Chad. It was more than a decade ago where telemedicine was not that famous like it's today. And when we had to do that, so we had to bring in a lot of technology. In the sense, we used Indian military service to even build basic internet there. Like if you have to build a telemedicine, you need internet. Somalia didn't have internet, so we had to bring internet first, and then bring. Then I came across uh, a lot of tech that's happening, which can really change the world. Because with very minimal people, we could really give a lot of great services to war zones where like doctors can't even go. So that really spurred my interest in healthcare technology, and it took me to Boston. I went to MIT after having done my MS and all the health tech. I again went to the school, so I did a master's, mostly working on machine learning there in technology. So that's that's what took us into building a health tech company called VIZZHY. That's what we are doing. So VIZZHY is doing something which we call as the metabolic signature. So what we do as a company is, if you see a lot of information is there in the body, which can tell us why exactly a disease has happened and what is the root cause of the disease. So it's hidden in our genes, it's hidden in our proteins, it's hidden in many things. When we do this test, what we end up is generating a lot of data. Like each metabolic signature we do generates 250 GB data, which is very unwieldy for anyone. The first set we did, it took us like 3 months to even like understand the data. So for us to just understand 107 data points, it took us 2 years. So after 2 years of starting a company, all I had is 107 data sets. That's when we said like this is so unwieldy. It's never going to click. Like it's a deep tech company, so nobody would invest in a company which takes 107 patients data sets. It takes 2 years. That's when I came across a group in India working in IIT who are building transformers, using transformers in healthcare. So I met them in Boston, and then I said, I want to start a project here in India. I came back to Bombay, and we started this. At that time, we didn't know that generative AI is going to be so popular. This was 3 years back. We said, like, we'll use transformers in our company, and then we funded a research project here. And it did very well. We built a lot of encoders, which really brought down the time which takes to understand our data sets. And then when we were working there, ChatGPT happened, and then the world changed. So ChatGPT became so popular. Then the same group who are working with us, they said we want to build BharatGPT. So I said like this great with a lot of information and knowledge we have been using. So maybe you should do that, and I can support you. So 7 IITs came together, and then they said like we'll do BharatGPT. And when we started doing that, the first problem we faced was, where is the compute gonna come from? So there were no GPUs in India, and hardly the compute of all the IITs was not even sufficing. So we went to a lot of places to ask for the compute. Have virtually met all the companies who manufacture GPUs, and the NVIDIA waiting period was nearly 52 weeks. They said, like, you order it today, we can deliver it 50 weeks. That's not even like, because when US and Gulf countries are buying in tens of thousands, if somebody goes from India and asks for, like, say, give me 256 GPUs, you'd be maybe 100th on the list. So virtually, it took us like many months to even like figure out where we are going to source the GPUs from. It took me to Taiwan, where I met a company who were doing OEM manufacturing for GPUs. We bought the first H100s to India. It's there in a data center in Bombay. So that's how our building generative AI for Bharat started. So, and then that really gave us a lot of insights on how to really do this, how to bring the H100s, how to even connect them, a lot of things. It took us 2 months to just piece those things out, because that's the kind of effort it needs when you don't have that infrastructure. So this is the background of how the whole thing started. Today, things have moved a lot, and we have a huge compute now. Like, I have 1,000 GPUs, which is working behind the models which we are building, and these models are being called as Hanuman. So when we announced Hanuman in NASSCOM conference, a lot of people even thought, is it a movie, Hanuman, which is come? So yeah, in fact, when we talk like why we even named these models as Hanuman, it's an interesting story. We went to Carnegie Mellon University, and then there were a lot of professors who were working on generative AI, and they said, you see, like, why many companies don't try to build this kind of things? Because it's a very responsible work. Like, AI is a very powerful tool, but you need to be super responsible, because many things can happen, and which you have to take a liability on. So if it's not responsible, you don't even try to do it. So you should have a big framework for what is going to be the responsible AI. This really put us back. Like, we were thinking on what is going to be a framework, like how do you even write a framework for responsible AI to make it so simple that everyone even gets it easily. That's when this idea hit upon us, that we were thinking about like what is going to be responsible AI. Then we understood that there is a huge framework in Hanuman itself for the responsible AI. Hanuman, if you go by aerobics, he was the most powerful entity. He had huge power. He could lift mountains. But if you see his life, he has never used it for his own selfish purpose. He could have become king of Lanka, but he told Vibhishan to become king of Lanka. So he always used with public good. He said, this is such a simple framework, which will give us like our model should be right. Like, so then we said, why don't we just even not just use this? Why don't we name it as Hanuman? Because we are building generative AI for Bharat, and something rooted in Bharat should be the name of our models. That's how the Hanuman model name came out. These are the use cases which we are addressing to Hanuman. So our biggest point in why we had to build something from foundation, if you see, a lot of people are trying to use models which are already been built there. There is even a huge conversation going on. Do we even need to build a foundational model? Why can't we just use open source models already available and then fine tune them? So we have also seen a lot of language models being released in different languages, which have been fine tuned on other models. But the biggest problem with something like that is, number one, if you see any big language model like, say, ChatGPT, it has nearly 90% English tokens. The German tokens are about 5 to 6%. Something like a Malayalam, which has about nearly 3 crore people speaking that language, has only 0.16% tokens. So that makes it very, very expensive to use something like that model for Indian languages. And if you see the India market, only 10 to 20% of us who are here can really use English very well. All the use cases I have shown mostly come from people who are in that 80% people who can't use English. So they need to work in their own language. Like a school kid in a village, would we have, if she has to learn physics, that's why Physics Wala is so famous, because he makes it so easy. He tells you in Hindi, so you get it easily. But if some elite school is teaching that course, somebody puts it on YouTube, it can't be accessed by that kid. So to build this kind of model from scratch up in India, we needed huge number of data sets. And they're not there in real. If you see English language tokens, there are nearly 30 trillion tokens available. Anybody can build an English language model, but you have to build a model in, say, Telugu, which is my mother tongue. There were only 7 billion tokens. With the 7 billion tokens, you can't build a model. It's going to be trivial. And if you take those little tokens and then use a English language model and then try to build a Telugu language model, it will be like putting 2 drops of water into a bucket and then thinking that the color of the water will change. And also the important thing is when somebody has to bring back the tokens, the model has to do a lot. So that's why it costs a lot if you ask ChatGPT to find a language token. Like we did a study where we saw that a language called Burmese, which has highest expense when it comes to tokens, it costs 300 times more than an English token when somebody has to bring it from Burmese language. So that's because the tokens are less. Now, our team has done a tremendous work on this. What they have figured out is Indian languages have something of a different architecture. Like English is A, B, C, D, E, and all Indian languages, you take anything, whether it is Tamil or Hindi or Assamese, they're all Kaka, Kagana, and I. So it's a different canonization. What we did was, there is a lot of similarities in languages. Telugu and Kannada are virtually, the script is same. Tamil, Malayalam, the script is same. Lot of vocabularies are same. So nearly, if you look at it from that perspective, 80% of Indian language tokens can be virtually used for any other language. They can be interchanged. Only that nuances are 20%, which is what our model has learned. So what it makes is, like there is something called double R. It's called Ra, which is only used in Telugu language. It knows that. So there is a word called La, which is not there in Hindi, but it's there in Kannada. So this way, there is a difference, but there is also a lot of, 80% is interchangeably usable. That's how we built our data sets from bottom up and then bringing these models, which will not have the dominance of English, but can speak in nearly 8 to 9 languages today. And our plan is to even release it for like small languages like Mizoram and Manipuri, which will take us to 22 Indian languages in next 2 years. And another biggest factor we have found out is, as even IBM research was saying, that the big models cost a lot to maintain. It's very easy to use a model in a POC, but if you have to use it on a large enterprise scale, it's going to be super expensive. It costs millions of dollars because they have put hundreds of thousands of GPUs to run that model. But if you go for a war, you need to have different kind of things. You need to have infantry, you need to have cavalry. You can't use, fighter jets for everything. So that's how we are building these models. Hanuman model will be, as small as 7 billion, 13 billion, and 40 billion. And because you don't need every skill to be for every use case. Few use cases need very limited skills. And for that, you don't need to take a huge model, which is like 175 billion parameter model, and then try to solve it. So the best thing is to use models which horses for courses kind of models. That's the, we also even call them as small language models. It's not small language. We just named it like that, which can be used on an enterprise. They can be deployed on a prem, and you can put your own data sources there and then use it. Because the biggest challenge would be, one, how the companies or anyone who is using this retain their IP, keep their data secure, can they manage it? The other one is, there are many use cases where where a country needs, sovereign models, like say if it's a defense or a banking, you don't want your data to go to, other country. So you want to have your own models where you have to use it. That brought us to a lot of government use cases which we are working on, where the data has to be sovereign. So we are working with them. The models work there, and then we use their data sets. They don't need to send their data to, other model, because ultimately you want to retain your IP. And most importantly, because of the way our language speaks, lot of applications which can be used in education, health sector. The last one which I showed is what our company is building in VIZZHY. It's a very high cutting edge thing for performance athletes. So anything from like a school kid learning physics to a high-end genomic data sets, we can use these models because they're very, adaptable, and they come with a lot of hybridization. And another important factor which we have also seen is the GPUs itself. There are like 3-4 companies who are making GPUs. NVIDIA is very popular because it works superbly well. Virtually, you can run anything on that, but it's also super, super expensive. There are other GPUs which are very difficult to work with. We work with all the 4 systems currently available, and we have learned a lot there, like how to use the other GPUs, which are costing less but very difficult to use. You have to build a lot of libraries, understand them. Basic things are also sometimes not there, but we have learned it. That way, our cost can come down, because if there is a competition in the GPU market, which is going to be the major factor for any generative AI product or a company running it, where you can use GPUs, like NVIDIA works very well in few things. For other things, like text and all, you can use other GPUs, but there are no libraries, it's very difficult to use. So this hybrid cloud is what we are trying to bring, where you can put other GPUs together and then bring down the cost itself. That's going to be the big change, a game changer for India, because if you can build models which are like data efficient, use less compute, and which can work in many other languages apart from English, India is surely going to be, generative AI model capital of the world. So that's our vision. That's what we are trying to do from Hanuman. And it's a public and government partnership, because a lot of universities, a lot of researchers who have worked before us have come together to build this. And that's what, we call it as India's first multilingual, multimodal language model built in India for the world. Thank you very much for patiently listening.